Hi, this is Lou Napoli. Today I'd like to speak to you about the push buttons on the SITRANS P family of transmitters. The push buttons are here on the top of the instrument. There are three of them. They're magnetic. There are no holes in this housing. Embossed into the cover, you'll see an M, an up, and a down. That stands for mode, which is the left-hand button, up, which is the center button, and down, which is the right-hand button. Those buttons are useful to set up the transmitter without the need for a HART handheld. Yes, our transmitter is HART compatible, but the push buttons allow you to do 85–90% of what most customers want to do without the need for the handheld. As I always say, you never lose this handheld. All right, let's look at the functionality of those push buttons. You push the mode button, and sure enough, you'll see, in this case, a 2 appear in the lower left-hand corner of the display. That means I'm in mode 2. In mode 2, this is where you would enter a pressure into the transmitter that you want to equal 4 milliamps. And then you use the up and down keys to adjust the output to be 4 milliamps. You'll notice the output is in milliamps in the lower right-hand corner. Now we move to mode 3. Mode 3 is where you input the full-scale pressure, the pressure that you want to equal 20 milliamps, and once again, you would manipulate the up and down arrow buttons to get yourself to 20 mils in response to that input pressure. That's pretty much the same as any zero and span pot in older transmitters or other types of manufacturers' transmitters. The next mode is mode 4, which is damping. You'll notice there's an S in the lower right-hand corner, and damping is, just as the name implies, how quickly the output will respond in response to an input pressure change. The next two modes are the most important modes that we have in this transmitter, and they are modes 5. And the first thing you'll notice when you go to mode 5 is the units of measure, in this case, are inches of water, which are pressure. Mode 5 is what pressure do you want to equal 4 milliamps. With our transmitter, you do not have to input a pressure in order to set up your 4 to 20 mils. You can use mode 5 to set up the pressure that equals 4 mils, and step to mode 6, which is the pressure that equals 20 mils. That's an important feature. Most customers will not have a pressure source that's accurate enough to set up an 0.75% precise transmitter well enough because the pressure source doesn't have that capability. So you're trusting the inherent 0.75% of the transmitter to set your 4 and 20 mil pressure points. There are some cases where you would use modes 2 and 3. If you had a tank and you don't care what the number is, you say, this is the level that I want to be 4 milliamps, well, you put that level on the transmitter, adjust in mode 2 to 4 mils, you raise the tank to its uppermost level that you want, and now you would go to mode 3 and set up 20 mils. You've now set up 4 and 20 milliamps in response to that low level or the high level, and you've set up your output. You don't need to know what the pressure was. But if you want to set up the transmitter in response to some known pressures, modes 5 and 6 are the way to do it. The next mode you'll encounter is mode 7. Mode 7 is a very, very powerful mode. It allows you to correct for position or impulse lines, things of that nature. And we're going to do another video that goes into that in detail. The next mode after that is mode 8. Mode 8, the transmitter will act as a current source. You hold both buttons down, and now the transmitter shifts to becoming a current source, and you can force 4 mils 12 mils, 20 mils through the loop, and now be sure that your HMI, your controller, whatever, will follow 0, 50, and 100% output current. That's a very handy one for the guys in the field, the technicians, the electricians, things of that nature. It allows you to take the transmitter and set up the loop very easily that way. The next mode you have is mode 9. In mode 9, you decide, where do I want to fail? What current level do I want to fail at should I have a failure? Fail-safe high, fail-safe low. Typically, most people, 95% of the applications, people choose fail-safe high, which in our standard fail-safe would be 22.8 milliamps. Some people might choose the low, which is 3.6 milliamps. But mode 9 allows you to do that. The next mode, mode 10, right now there's a 0 in the display. 0 in the display means there's no limits to what you can do with the push buttons. You might see L0, LS, those allow you to set up zero-based things. LS allow you to set up span and zero-based things. L is the most locked up. You can lock this transmitter. If you leave it in the L mode, the transmitter push buttons will not do anything. That's not true security, because if you set it up, if you lock out the push buttons with the push buttons, we have to allow you to be able to unlock them with those same push buttons. So our way of unlocking is to hold the mode button down for 5 to 7 seconds. That's a long time when you think about it. It's not true security. Mode 10 doesn't allow you to lock things out truly securely, but it's a deterrent. It's more a deterrent. If you really want to lock a transmitter's push buttons out, you would use a HART device and put the transmitter in what's known as the LL mode, which means only a HART device can talk to it. The next mode you'll encounter is mode 11. Here, this transmitter is set up in the linear mode. As I input pressure, it will respond the output in a straight line between two pressure points that I've chosen, perhaps in modes 5 and 6. What you can get with a DP transmitter is take square root in the transmitter itself, so that measuring the pressure across an orifice plate, a venturi, a pitot tube, those flow elements are what are known as square law devices. If you take the square root of the differential pressure, that is linear with flow. So this transmitter in mode 11 can be set to do one of 3 different square root type responses to that input pressure to be linear with flow at the output. I'm going to leave this transmitter in the linear mode right now. But once you pick square root function, you'll see a little square root appear in the bottom line of the LCD, telling you that you're taking square root in the transmitter, so you don't take square root in the control system as well. The next mode is mode 12, which will only appear if you have chosen a square root function. That is the percentage output where you will jump onto the square root curve from one of the 3 different square root functions that we have built into the transmitter. The next mode you'll encounter is mode 13. In mode 13, you decide whether you want the transmitter in normal operation to read engineering units, in this case it's inches of water, or output milliamps, or percent output. Those are the 3 things that this transmitter in actual use would do. It'll either read the inches of water or pressure units, engineering units, or the milliamp output or percentage output. That's really what the transmitter LCD will give you. In mode 14, you choose what engineering units of pressure do I want to work in. Here in the US, that would be inches of water, feet of water, PSI for pounds per square inch. torr perhaps if you're doing vacuums, millimeters of mercury if you're doing vacuums. Those are the main pressure units that we use here in the United States. What you would do is, here in mode 14, if I wanted to go from inches of water to feet of water, I would simply scroll through, here's feet of water, and I hit the mode button, and now the output will show feet of water on the display for the transmitter. Okay, I hope you can see the power that these simple little push buttons give you in how to set up the transmitter. As I said at the beginning, this allows you to do 85–90% of what most customers need and want to do. So, if you have any questions, please review the video or give us a call at tech support and we'll be happy to help you do that. Thanks.